累了，我把电视。
Okay, hi everyone. Mm, Okay, so good morning. So this is a sharing sections. Like I try to summarize a topic uh, under the network technology. So this topic is transmissions media. So the approach here is this is more like a summary, which is help you to grasp a little bit more the information in this transmissions media, this topic. Okay, so the approach I'm using here is also like I make use of the AI to summarize the topics which is under this transmissions media. So, all right, so let us start. So the first one is what is transmission media? So transmission media is the physical path through which data transfer from one device to another uh, using electrical voltage pulse or electromagnetic wave, EM wave. So it is essential for transporting a signal in the network. Okay, so transmission media refer to the physical or wireless channel used to transfer data from one device to another in a computer network. Okay, data is transmitted as either electrical voltage pulses, okay, in a wired media, or electromagnetic EM wave, okay, in a wireless media. So characteristic of transmission media. So when choosing transmission media, you just keep in mind some of the points like cost, okay, bandwidth, ease of the installations, uh, attenuations, and immunity from the electromagnetic interference, EMI. So cost is actually the expense of the installation and the maintenance. Bandwidth is the amount of the data a medium can carry, measured in the bits per second, like bps. For example, the Ethernet cable can transmit 10 Mbps, the basic one. So ease of installation is like some media types are easier to install and configure than others. So attenuation is like the signal will be weakening over the distance. So you see how strong the signal can be maintained throughout the whole distance. So immunity from electromagnetic interference, EMI, is the ability to resist interference from nearby electrical devices. The resist interference. Okay, so type of the transmission media. So there are two main type of the transmission media: bounded, which is wired, physical cable that used to transmit data like a copper or the fiber optic cables. Unbounded is the wireless data transmission without any physical cables like radio wave and microwave, right? So again, as I said, this is serve as a summary. So the purpose of this sharing section is to have summarize all the points using the AI, and the purpose of this is just to help you to grasp the all this topic more faster. All right. Okay, let's continue. Wired, or we call the cable media, or we call bounded media, or we call wired transmissions. Okay, so bounded media involve the use of physical cables to transfer data between devices. There are three main type of the bounded media. So twisted pair cable. So the structure is the twisted pair cable consists of two insulated copper wires twisted together to reduce interference. Okay, the type. So unshielded twisted pair UTP. So most common, cost effective and easy to install but more vulnerable to electromagnetic interference EMI. Shielded twisted pair STP. Okay, there are two. Okay, include extra shielding to reduce interference, often used in industrial environments. Okay, there are two unshielded and shielded. So category like 1 to 2 used for voice transmissions, such as like examples of telephone lines. Category 3 to 7 used for data transmissions, with newer categories supporting higher speeds. Okay, example the category 5E, or we call the Cat 5E, is the commonly used for the Ethernet network, the Ethernet LAN, using this Cat 5E. Advantage: inexpensive, easy to install and manage, widely used. Okay, the advantage: limited to distance like 100 meters max for Cat 5E, and sensitive to interference. So I have a small summary here. So twisted pair cable, commonly used in LAN topology. So shielded STP has extra protection from the electromagnetic interference. Unshielded UTP, more common, more affordable, but less resistant to the EMI. So example here, Ethernet cable in the home and the office. Next, coaxial cables. So how is the structure? So coaxial cable have a center conductor surrounded by insulations, a metallic shields, and an outer insulating layer. The shielding help prevent electromagnetic interference (EMI). So the type is there are two baseband coaxial, we call thin net. Okay, used for digital signal, typically in Ethernet network with a distance up to 185 meters. Okay, broadband coaxials, thick net. Okay, support analog signal and longer distance. Okay, up to 500 meters. Okay, this you have to remember. Okay, advantage: better EMI resistance and capable of longer distance than a twisted pair cables. Okay, the advantage: bulky and harder to install than twisted pair cable, and more expensive. Okay, so the summary, a small summary here. So coaxial cable, first used in LAN. Coaxial cable are known for longer distance and higher speed. So, for example, the cable TV use coaxial cable to transmit TV signals, right? So maybe this one is more familiar to you guys. So fiber optics cables. So structures. Fiber optic cables use light pulse to transmit data through a glass or plastic core surrounded by cladding and protective layers. So they are type like single mode fiber SMF, support long distance communication with high bandwidth, typically used in WAN topology and some undersea cables. Okay, multi-mode fibers (MMF) used for shorter distance with lower bandwidth, often in LAN. Okay, so advantage: extremely high bandwidth, up to 100 gigabit per second or more, immune to the electromagnetic interference (EMI), support long distance, several kilometers. Okay, the advantage, of course, is expensive to install and requires specialized equipment and skilled technician for installations. Okay, because fiber optic is very fragile. Okay, so a small summary here. Fiber optic cable transmit data using light instead of the electrical signal. It is ideal for high speed, long distance communication. So examples, ISP, so internet service provider, often use fiber optic cable for high speed internet connections. Okay, next, wireless media, or we call unbounded media or wireless transmissions. Okay, so unbounded media transmit data through the air using electromagnetic wave. Okay, the main type are, okay, radio wave. So the frequency range is typically between 10 kilohertz to 1 gigahertz. Okay, something like this. So applications is like used in the wireless LAN, Wi-Fi, Bluetooth, mobile communications. So advantage is like can travel long distance, easy to set up and support mobile user. The advantage, limited bandwidth, prone to interference, and can be intercepted easily without encryptions. Wi-Fi, right? So it's easy to be intercepted, right? Next, microwave. So frequency range between 1 gigahertz and 300 gigahertz. So type uh, terrestrial microwave. Okay, require line of sight transmission between antennas, commonly used for long distance communications like TV broadcast, telephone system. So there is some ground type antenna, and then transfer using some beams of the radio wave. Okay, so satellite microwave. So data is transmitted between the ground stations and the satellites in the orbit. Wow. Okay, so this allowing communication over vast distance because it's connect transmit between the ground station and the satellites in the orbit. So definitely it can cover a very vast distance. So advantage, high bandwidth, support long distance communication. So the advantage is susceptible to interference from weather conditions like rain, fade. Okay, some weather conditions require expensive equipment. You need to build the antenna. You need to build all the, the ground based antenna and so on, the stations, the satellite and so on, right? And you need to use the line of sight, I think is the beams, beams of the radio wave. Okay, transmissions. So next is infrared. Okay, frequency range between 1012 to 1014 hertz. Okay, applications used in a short range communication system such as a TV, remote control, virus keyboard, and file transfer between devices. So advantage, secure communication within a small area, relatively inexpensive. The advantage, very limited range, 1 to 2 meter, require direct line of sight and cannot penetrate the wall. So the light cannot bend one. You need to go straight one. Infrared lah. That's my understanding. Next, this one may be more familiar with you guys. Near field communications, NFC. So the application used for very short range of the communications, such as contactless payment, Apple Pay, Google Pay, and others lah. So and secure data transfer between the devices. Advantage, secure, fast, convenient for close proximity. Okay, proximity, very close proximity data exchange. The advantage, of course, is very short distance, very short, just a few centimeters, limited to specific applications. Okay, So this is a small summary. Virus media transmit signal without cables, and the Earth's atmosphere act as the medium. Okay, so the type include like radio wave used for mobile phone, Wi-Fi, FM radio, microwave used for satellite communications and long-distance telephone transmissions. Infrared, common use in remote control and short-range communication between devices. Near-field communication (NFC) used for very short range of data transfer, like contactless payment system. So example, Apple Pay, Google Pay, and so on. All right, next. Okay, next, bandwidth and capacity. Okay, so bandwidth, okay, what is mean by bandwidth? So the amount of the data that can be transmitted through a transmission medium, typically measured in bits per second. Okay, bps. Okay, factor affecting the bandwidth, the cable length. Okay, longer cable can lead to signal attenuation. Attenuation meaning the signal weakening over the distance or the journey. Okay, reducing the bandwidth. Okay, media type, fiber optic cable have higher bandwidth than copper cables. Okay, multiplexing. Okay, multiple signal can share the same medium using multiplexing technique. So later we will talk a little bit time division multiplexing, frequency division multiplexing, right? So band-based transmissions. Okay, now this recap a bit okay, so a definition: use the entire bandwidth of the medium for the single communication channel. So the application commonly used in the Ethernet LAN, transmitting digital signals. So example, Ethernet network in the office using a dedicated cable for each connections. Okay, baseband transmission. Remember earlier we mentioned about it inside the inside this what is it, band base moment. The here, okay, yeah, here. Okay, so we just make it more clear a little bit more. Right. So next, broadband transmissions. So the definitions: divides the bandwidth of the medium into multiple communication channel, allowing simultaneously transmission of multiple signals. Okay, applications used in the cable TV where different channels are transmitted over the same cable. So example, watching multiple TV channel over a broadband cable network. Okay, so a small summary here. So bandwidth, okay, about band base and broadband. So band base is, okay, devotes the entire capacity of the medium through one communication channel. Only one signal is sent at one time, but multiple devices can communicate using time division multiplexing, TDM. Okay, example, Ethernet network. So broadband allow multiple communication channels to share the same medium using frequency division multiplexing, FDM. So example, the cable TVs, televisions, where different channels use different frequencies. Okay, so next, multiplexing techniques. So multiplexing allow multiple data streams to be transmitted over the same medium, improving the efficiency of bandwidth usage. So earlier we mentioned, right, the TDM, time division multiplexing. Okay, how it works: divide the communication channel into time slot, with each device assigned a specific time slot to send. Okay, application used in telephone network and digital data communications. Okay, for example, four devices share one communication line, with each device transmitting data during its assigned time slot. Okay, so another one, frequency division multiplexing, FDM. So how it works: divide the channel into multiple frequency bands. with each band carrying a separate signal. So application is like used in the broadband communication such as cable TV and radio broadcast. Example, multiple TV channels are transmitted over a single cable using different frequency bands. Okay, so a small summary for this multiplexing. So multiplexing allow multiple signal to travel over one single medium simultaneously, increasing efficiency. So there are two multiplexing: time division multiplexing (TDM), divide the time slot for each signal. So example, multiple phone communications conversations over the telephone line. Frequency division multiplexing (FDM) split the bandwidth into different frequency bands for each signal. For example, the FM radio station use different frequency to broadcast at the same time. Okay. So next, electromagnetic interference. Okay, EMI. So the definition: unwanted electromagnetic signal that interfere with data transmissions, causing noise and signal degradations. So sort of the source of the EMI, electrical devices such as motor, microwave, fluorescent lights. Okay, so way to mitigate the EMI, you can decide to use the shielded cables, STP coaxials, keep network cable away from sources of EMI, or use the fiber optics cable, which is immune to EMI. But I think when you Google more, or you do your own study, I believe there will be more ways to mitigate the EMIs. So in here is use shielded cable, STP. Okay, keep the network cable away from all the sources of the EMI. Okay, for example, the motors, microwave, fluorescent lights, and so on. And of course, you can use fiber optic cables. Okay, so a short summary here for the EMI. So EMI is unwanted noise from electrical devices that can distort the signal, causing data error. It is important to choose media type with protection on EMI, such as shielded cable or fiber optics cables. Okay, now I keep repeating the at attenuations, right? So I give you another a bit definition here. The a gradual weakening of a signal as it travel over the transmissions medium. So the signal is getting like weaken. Okay, the effect as the signal loss strength, it become harder for receiving device to distinguish the original data from the noise. So the solutions, you need to use repeaters to amplify the weakened signals, limit the length of the cable run to reduce signal degradations. Yeah, again, there are a lot of solutions, I believe. So these are the two mentioned. So use repeater, use amplifier or something like that, and then you limit the length of your cable to reduce the signal degradations. So yes, this come to the this transmissions media, the summary. So transmission media are the critical component of network infrastructures with both wired and wireless options, offering a unique advantage and trade-off. So you decide. Okay, depend on what. So earlier we have mentioned, I mean, of course, there are a lot of the factors here. So these are just some factors I mentioned here, like the number one is always the money, the cost, and then the bandwidth. So how fast you want, okay, and then how complex you want, okay, and then the attenuation, okay, you must know the signal will get weakened over the distance, and then also you need to take into consideration of the EMI, okay, electromagnetic interference, okay, all these are factor. Okay, or you can come up with your own if you can think of some other thing. Yeah. So when designing a network, it is important to choose the right medium based on the factor like cost, bandwidth, ease of installation, and immunity to the interference. All right. So that's all for this uh, the summary. Okay. Again, so here there is some of the questions or checking your understandings like for example differentiate okay the band base and the broadband. Okay, so band base, so it is use the entire bandwidth of the transmission medium for the single communication channel. So it use a digital signal, meaning binary lah, value 01100110 something like this, support bi-directional communications. So example, Ethernet networks where the single device use the whole medium to send data. Okay, the Ethernet. Okay, broadband divides the bandwidth into multiple communication channel, allowing simultaneous transmissions. It is using analog signal carrier wave broadband, right? So no cable, ma. Okay, support unidirectional communications. Unidirectional communications. Example, cable TV, where different channels are transmitted over the same cable using different frequency band. Okay, so you must know how to differentiate baseband and broadband, right? Baseband, binaries, digital. Broadband, analog, okay, carrier wave. So broadband divide the bandwidth into multiple communication channels, simultaneously transmission. Baseline, one, single, okay, for transmissions. Next, okay, so let's say you are asked to explain for the frequency division multiplexing, FDM. So frequency division multiplexing, it is divide the available bandwidth of the transmission medium into multiple frequency bands. Each frequency band carries a separate signal, allowing multiple signals to be sent simultaneously without interference. Example, cable TV. Different channels are transmitted over different frequency through a single cable. Okay, this is definitions, some explanations, and then the examples. Okay, let's say now describe time division multiplexing. Time. So time division multiplexing meaning he divide the transmission time into time slot. Each device is allocated a specific time slot to transmit data over the transmission medium. So all devices share the same channel but only transmit data during their assigned time slot. Okay, example, the digital telephone system use TDM to share a single communication line among multiple users. Okay, digital telephone line use TDM to share the single communication line, but among multiple users. All right. So if you still think that these two are a bit hard for you to visualize, I would encourage you go for other YouTubes, go for AI, go for Google. So don't limit yourself. Okay, just find out more explanations. Okay. So how does the crosstalk occur in a twisted pair wired? So crosstalk occur when an electromagnetic signal from one wire interfere with the signal on an adjacent wire, okay, causing the noise and degradations in the signal quality. So twisted pair cable are designed to reduce crosstalk by twisting the wire together, which help cancel out the interference. So how that is occur? Because is the electromagnetic signal from one wire interfere with the signal on an adjacent wire, so causing noise and degradations. So crosstalk is a noise lah. So how to reduce it? you need to use a twisted pair cable. Okay, this is the suggestions here, right? So now maybe you will be asked to explain twisted pair cable. So twisted pair cable, there are a lot category 1 to 7. So a twisted pair cable consists of two insulated copper wires twisted together to reduce electromagnetic interference. Two type: unshielded twisted pair (UTP) and the shielded twisted pair (STP). So commonly used in the land, is affordable but more vulnerable to the interference. Okay, shielded twisted pair offer additional protection against interference, often used in industrial setting. So the example, the Ethernet cable like Cat5e, Cat6. This is the common one used for the your LAN topology. Okay, in your home or in the office, you will see all the cable, Cat cable, LAN cable, Ethernet cable, something like this. All right. So you might be asked about this term. Okay, thin net, thick net. So thin net means baseband coaxial cable. Okay, thick net, broadband coaxial cable. So thin net used for shorter distance up to 185 meters, thinner 0.25 inch or for okay, in thickness, and more flexible and make it easier to install. Okay, thick net support longer distance up to 500 meters, so thicker, approximately 6 to 18 millimeters, okay, so harder to bend, very hard to bend, more expensive to install than thin net. Okay, this is just a basic comparison. Thin, very thin. Okay, thick, very thick. Okay, when you thin, you're shorter distance. When you're thicker, then you can support longer distance. Okay, when longer, more expensive. Okay, shorter, simple, flexible. Okay, that's the comparison. All right, so you might ask to like give advantages and disadvantages over the fiber optic cable. So of course, advantage is high bandwidth lah. So fiber optic cables can transmit large amount of data at very high speeds. Okay, from 100 Mbps to more than 2 gigabit per second. Immune to electromagnetic interference (EMI), since fiber optic cables use light instead of electrical signals, so they are unaffected by this EMI. Okay, then the other side, okay, the advantage. So expensive. Fiber optic cable are more expensive to install and maintain compared to others normal copper cables. So and then you also need a specialized equipment. Okay, require installing and handling fiber optic cables require specialized tools and skills. So in other hand, also means it's more complex for installations. Okay, and see the difference. So next, okay, maybe this like just tapping down. Okay, so why fiber optics cable immune to electromagnetic interference? Okay, if you remember, I mentioned fiber optic cable use the light beam, okay, light pulse, okay, to transmit data through a glass or plastic core, which is not affected by electromagnetic fields. Since they are not relying on electric signal, fiber optic cables are completely immune to electromagnetic interference (EMI). Okay, so next, so you might ask to differentiate like terrestrial microwave and the satellite microwave. So terrestrial, okay, microwave, okay, use line of sight transmission between the ground-based antennas. So in which is like transmit tightly focused beams of the radio signal from one ground-based microwave transmission antenna to another. Okay, typically used for long distance communication across land, like in a telephone or TV network. limited by the curvature, I mean the Earth and physical obstacles. Okay, obstacle. Okay, so satellite microwave. It is involved communication between the ground station and the satellites in the orbit. So which means it works similar as terrestrialized, okay, terrestrialized or microwave, except the signal travel from the ground stations on the Earth to the satellite and back to another ground station on the Earth. Okay, so it can cover much longer distance lah. Can be say global coverage, but it is very expensive and prone to weather related interference. All right, you need to build the station, right? You need to build the antenna, and you need to build the satellite and so on. Okay, you need more expert to handling it. So example of the application area like virus transfer of electronic mail, video conferencing. So that's how the example provide lah. Okay, so um, okay, so that's the 9 questions I prepared to checking for your understanding. So I think with this we are cover the transmission media this topic, and again as I said, this is just a summary notes. Okay, okay. Please do not limit yourself. I always repeating myself. Start your own study. Write your own notes. Okay, using all these AI utilities, Google search, start your readings. If you prefer the books, you go for the books. If you prefer some research paper, you can go for Google Scholars and start do some practices. Okay, practice make perfect. And yep, that's all. So I'm going to stop the video right now. Thank you so much for watching. Thank you. Okay, bye bye.